Okay, so today is day 35. We are starting limiting reactant, which is the last topic in chemistry. Hallelujah, we're almost there. Okay, all right, so limiting reactant basically means, like, if you remember when we did the simulation a couple classes ago with the sandwiches, okay, basically if you say you are trying to make the ham and cheese sandwich and you run out of cheese first, right, then that was what we call the limiting reactant. Or say that you run out of bread first, that means that bread is the limiting reactant, okay? So the limiting reactant is basically whichever one of the starting pieces runs out first, and therefore limits the amount of product you can make, okay? So you could have like 25 loaves of bread, but if you only have 4 pieces of cheese, you're only making 4 sandwiches, all right? So then cheese would be the limiting reactant, okay? So as far as the chemical equation, balance the equation showing hydrogen and oxygen forming water. Okay, so I see over here 2 oxygens and only 1 over here. So I know that's going to have to be at least a 2 to make it even. Okay, so 2 oxygens, 2 oxygens. That looks fine. Okay, and then now on the right side, I have 4 hydrogens. So I need to put a 2 here, so I have 4 hydrogens. So that's going to be a 1. All right. Okay, so the recipe, right, is going to be 2, 1 makes 2, right? But we might not start with 2 and we might not have 1 to make exactly 2. All right, so let's say that we start with 4 moles of hydrogen gas, okay, and 4 moles of oxygen gas. So before, in the what we call the reaction container or the reaction vessel, we're going to draw 4 H2s. Okay, and we're going to draw 4 O2s. Okay, because I'm going to start with 4 hydrogens and 4 oxygens. Okay, we want to know then how many moles of water can be produced. Okay, so every water is going to be an H2O. So basically, one of these hydrogens and half of this oxygen is going to come together to make a water. Okay, so like there's a water. Okay, I can take another one of these hydrogens and the rest of that oxygen, okay, to make another water. Okay, and I'd like you to draw this along with me. Ideally, maybe if you have paper, it might be a little hard to do it with a computer, but, you know, do what you can, okay? All right, and then we're going to take another one of these H2s and then another half of this little guy. And then we're going to get another water. Okay, and then we can still keep going. We can take these other hydrogens and the rest of this guy to make yet another water. Okay, all right, so I was able to make 4 waters here. All right, but I can't make any more because if you look over here, right, I'm all out of, oh, that doesn't look so good. I'm all out of hydrogens, okay? I've already used all my hydrogen, and then I used 2 of the oxygen, but you can see, I need a lighter color here. Okay, but these 2 oxygens, if you can see, these are left over, okay? So if I'm going to draw in my reaction vessel, I'm going to draw those 2 leftover oxygens. That would be left, okay? Because all of these guys were used up in the reaction, but these oxygens here were left over, all right? So if I look at this, I'm able to produce 1, 2, 3, 4 moles of water, okay? The reactant that's in excess is going to be oxygen, okay, because I have some left over, all right? Oops. Why do I keep doing that? I can never figure out how to get out of this. There, okay. Oxygen left over. Okay, and then how much is left over? I had 2 moles of oxygen left over. Okay, which means in this case, I would call hydrogen is the limiting reactant, right? Because hydrogen is going to be the one that's going to get used up first. Okay, all right, if I want to use a Bca table to do that, 2, 1, 2. Okay, I would have started with 4 and 4. No product. All right. Now I need to figure out which one's going to run out first. So one way you can do it is just pick one, see how it goes. Okay. If somebody comes out negative, then that's not right because you can't have a negative amount. All right. Or sometimes you can sort of reason it out. Okay. So in this case, I'm going to go ahead and reason it out because I know I need twice as much hydrogen for half as much oxygen, right? So I know that I'm going to need more hydrogen than oxygen, okay? So then since I'm going to need more hydrogen than oxygen, the hydrogen is going to be the one that's going to run out first because I need more of it, and I'm starting with the same amount, okay? So since I'm starting with the same amount, this one's a little bit easy to see. I need twice as much hydrogen, so that's going to be the one that's going to run out first. So I'm going to subtract 4 to be left with nothing, okay? And then that's going to become my basis for everything else. Okay, so if you're not good at the regular stoichiometry already, you need to go back because you're not going to be able to do this if you can't do what we did the last couple days. Okay, the given on the bottom, 2 to 1, or 2. So this is going to be a 1, this is going to be a 2. So that means I'm going to use 2 moles of this, and I'm going to create 4 moles of this. Okay, so I'm going to get 2 moles of O2 left over, and 4 moles of water created, which you can see that's what we got up here also. Okay, so how many moles of water will be produced, which is going to be 4. Okay, which reactant is in excess? I can see that's a 0, which means it was used up. So this 2 moles of oxygen is what is left over. Okay. Oh, I guess I'll write 2 down here. Okay, and this one I'll just say oxygen because it's left over. Okay. All right, so based on your 2 methods of analysis above, drawings and the Bca table, what determines how much product can be made from a particular reactant mix? Okay, the product is determined by the amount of product determined by the amount of the limiting reactant. Okay. All right, so again, it'll get a little easier. You just have to kind of go through it. Okay, let's do the next page. Okay, balance the equation for the formation of ammonia from nitrogen gas and hydrogen gas. All right, so let's see. I have 2 hydrogens here and 3 over here. So that's going to be one of those 2 3s to make 6. Okay, and then if that is now 2 nitrogens over here, I already have 2 over here, so I'm good to go. All right, okay, this one's going to be a little bit harder to draw. If I'm given 6 moles of nitrogen and 12 moles of hydrogen, okay, so let's call hydrogen is going to be red. Oh, I was going to make it blue, but that's bad for SI, right? So let's don't do that. That's going to be oxygen. Nope, nitrogen. Okay, all right, so if I'm going to start with 6 moles of nitrogen, okay, and remember it's diatomic, right? So they're going to be actually 12 atoms. 5, 6. Okay, 6 moles of nitrogen. And I'm going to start with 12 moles of hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I'm going to do the same thing like before. All right, I'm going to go ahead and just kind of cross them out as I go because that's kind of a good way to learn it. All right, so I'm going to put that onto yellow. All right, so every product molecule is going to be an NH3, okay? So that means I'm going to need to use 3 H's, half of that one, and 1 N, okay? So I'm going to have 3 H's and an N, all right? Then I'm going to have another, I'll take that one and this next one, 3 H's and an N, okay? So that's going to be 3. Okay, now you don't have to do this every time. This is a little bit tedious, but I just kind of want you to see what I'm doing, okay? All right, let's do another one. So another 3 H's, so I'll take that one and one of those, and one of these guys. So that's another 3 H's and an N. I know this is a little bit tedious. And then another one, 3 H's and an N. So that'll be another 1. I'm making a video, get out.
What do you want to talk?
Not right now. Another 3 and another 1, another 3 and another 1, another 3 and another 1, another 3 and another 1. Okay. All right. So total now you can see I've used 1, 2, 4, 6, 8 hydrogens. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Okay. And I've used all these. Oh, sorry. That was nitrogens. Shoot. I'm going to confuse you. Okay. So I used 8 nitrogens. Sorry. 8 nitrogens. 2, 4, 6, 8 nitrogens. And then 1, 2, 3, 4, 5, 6, 7, 8 times 3, 24 hydrogens. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So I've used up all the hydrogen. Okay. And then I have nitrogen left over. All right. So I can see these guys are left over. So they're going to transfer into the reactant vessel here because they're left over. Okay. All right, so how many moles of ammonia can be produced? I was able to produce 8. Okay, in excess is going to be nitrogen, okay, which means hydrogen, again, is the limiting reactant because that one ran out first. Okay, and then I have 2 moles of ammonia left over. Okay, 1, 2. Okay. All right, so that's how you draw it. If you need to draw it for a while, go ahead and keep drawing it, okay? So you're going to have to draw 2 more, and then after that, you won't have to draw them anymore, okay? All right, so then this was, what was this? 3, 1, 2, 3, 1, 2. I started with 12 hydrogens. I started with 6 nitrogens and no product, okay? Right, so again, you can kind of maybe see what's going to happen, right? Because I need 3 hydrogens for every nitrogen. Okay, so if I have 6 nitrogens and I need triple the amount of hydrogen, I'm going to need 18 to make it work. Okay, but I only have 12. All right, so that way you know that nitrogen is going to be the limiting reactant. Okay, don't write this, but let me show you something. What if I decided this? Don't write this. This is not right. Okay, if I decided this, right, I would have 3 to 1. Oh, wait, that is what it is. Hold on. That is what I want you to do. No, other way. Sorry. Say I did this. Okay. Right. 6 minus 6 is 0. And then I did this here. And I did 3 to 1. And I get negative 18. Right. Then what's going to happen is 12 minus 18 is going to be negative 6. I can't have that. Okay. So if you can't reason it out, just pick one and do it. And if it comes out negative, then erase it. It's not right. Okay. All right. So let's try the other way. So I'm going to try that one. Okay, and then that's going to end up being the right one. So let's do the ratios. Okay, so this one, remember the given goes on the bottom, so the 3 goes here. Bring down the coefficients. All right, so 12 times 1/3 is negative 4. So 6 minus 4 is 2 moles of nitrogen. That's my leftover. Oops. Oh my God, I should not be making videos at midnight. That's not a good idea. Sorry, nitrogen. Okay, so 2 moles of nitrogen are left over, all right? And then here I make 12 times 2, which is 24 over 3 is 8. Okay, and then there is that one. Okay, so how many moles of ammonia can be produced? It's 8. All right, the nitrogen is in excess, which means that hydrogen's the limiting reactant. And how many moles are left over? 2. Okay. All right. Now I want you to, oh wait, one more question. Describe what you must look for in a particular reactant mixture to decide which reactant will be in excess. Okay. Basically, you need to look at the ratios and see what runs out first. And you can draw it too if you want. That's the limiting reactant. Okay. The one with leftovers is the excess reactant. All right. And again, remember, if you're not sure, it's okay. Just pick one. Do it right here and pick one. And then if it comes out negative, then you know you picked wrong. Okay. If it comes out with 1 is 0 and 1 is positive, you did it right. Okay. All right. So next I want you to do these 2. Okay. Try to do this. It's exactly like the ones we just practiced, but actually draw them and really do it and think about it. Okay. You need to spend some time thinking about it. Okay. The answer key is there, but it's on the next page. All right, so there's 2 of these, all right, and then check the answer key to make sure that you know what you're doing, All right. After that, then you're going to watch one more video and do another quick problem. Okay. So this is just kind of an intro, and then next class we'll practice this some more. All right. If you're struggling with this and you don't understand it, just contact me and we can set up a Zoom call. All right. I'm more than happy to help you. I have plenty of time to do that, but I need to know that you need help. All right. So please reach out to me.